So I'm not sure if the sound is coming through. I'm doing a test right now. Well, this is the Fixed Protocol channel. I am not sure what the story is with the sound, but apparently the sound is coming through, at least of my voice, but there is no music. I don't know what's up with that, but I'm not going to let that stop me. First of all, let me clear up some details for certain people that I know are going to come in here and watch the live stream, and they're going to read the title, "Why Am I So Smart and Know Everything?" Who is this arrogant guy who thinks he knows everything? No one knows everything. Who is he been talking to? Well, I don't know everything, and the title of this video is a little bit sarcastic. What it's based on is some comments that I received in one of my recent videos about Arduino. Someone was commenting that they were surprised that I knew as much as I did, because there's a lot of random information in my brain, and I'm going to explain a little bit about why that is. Why do I know so many different things about so many different topics? Um, that's just a characteristic of my personality. But more importantly, this is going to introduce a new series that I'm really excited to share with you, which I am calling, for now, I guess I'll stick with the name, I'm calling it the new Techno Retro series. So because I am such an old fart, a lot of times people, well, it's not because of that, but a lot of times people don't realize that some things that they know or are familiar with, they don't appreciate the value of this information, because we kind of see the world from our own perspective, right? So a lot of times, the things that you don't feel like it's special, because to you it's not special, right? Because it's your experiences, right? But we all have different experiences. We all come from different backgrounds. So, you'd be surprised to know that there are people out there that'll be very interested to hear about certain things that you experience that they don't know anything about. So, with that in mind, and with me being such an old fart, I thought I would talk about technology. Talk about historical technology in terms of, when I was a child growing up, and, just the contrast. I'll just give you a little glimpse into what I'm talking about. Let me get this off the screen. There's my ugly face. All right, now the party is started. So let me see if I can give you an example. So let's talk about the internet. We're going to be talking about this too. I was flipping through this while I was talking to you. Popular Science Magazine. This is probably the first time I bought a magazine in, I don't know, 10 years. But as a kid, I hate the lighting on this. As a kid, man, oh man, and this is pre-internet, these were lifesavers, because before you had the internet, this was really, yeah, I don't know where else you get that kind of information. This is where TV, right? So TV, you had TV, and then you had magazines. With TV, we didn't have cable for a lot of the time, so we didn't have a lot of specialty channels. So the most educational. You got PBS. They might talk about some things. But when you're looking for specialized knowledge on certain topics, magazines were the way to go. You want to learn about robotics, you can buy a robotics magazine. You want to learn about cars, you get a cars magazine. You pick your topic, there's a magazine, you go out there and buy it, and you can learn about it. And the beauty about magazines is that certain ones, right? Like Popular Science. I was very big. I loved me some Popular Science. Oh, I'm geeking out right now. But I absolutely love the Popular Science magazine. I just happened to see this by coincidence in a store recently, and I was like, oh, Popular Science, I remember you. And then I saw they were talking about DIY hacks and builds for makers everywhere. And since I'm just getting into Arduino, I said, hey, okay, let me see what the magazine has to say. And it's interesting because I feel like online, there's so much information. I don't know how these magazines even survive. I mean, I guess they survive because of idiots like me that buy them. Well, I'm being silly. But still, you'd think that anything they have in here, I could in theory get online. But then again, take a look at this. I mean, they're talking about building a smart home sensor, and they got a nice official schematic in there. You know what I mean? So, and this is a professional magazine, so there's going to be a certain standard in terms of that the information has to be versus a website. You know, it's just some guy in his spare time. You know, he may be accurate, may not be accurate. He may sort of slap together a diagram. Maybe he's not really good at it. But with a magazine, you know, everyone is trained and this is what they do. So obviously a much higher standard, much more consistency. So that would, to me, would be the value still of magazines in today's day and age. But anyway, let me give you an example. So let's talk about the internet. And I'm so excited to talk about this stuff. This is really, I know I'm geeking out, but this is really awesome. So the internet today, let's start with today. So internet today, no one really thinks about the internet, right? The internet's not even, I don't think it's even a thing anymore. I mean, it's just, the internet is no more a thing than air. The internet is no more a thing than, you know, I don't know, what can I think of? Electricity. I mean, these are obviously they're things, right? But no one thinks about electricity. Like, do you have electricity in your house? Oh, my electricity is really nice. Like, no one cares about your electricity. No one cares you have a phone, right? No one really cares that you have the internet. I mean, internet it's a utility at this point, and I mean, literally, you got homeless people with the internet at this point, right? So that is where we're at, right? It's here, it's everywhere. Everyone has it. It's in the office. It's on your phone in your pocket. It's on your desktop at home. It's free at Starbucks. You know what I mean? Internet everywhere. Now it's in your appliances, right? So yeah, that is today the internet. Now, and I guess I'll end before I go back in the past. I'll end with something else. So internet is everywhere. It's always available. You got high speed. I mean, I can watch HD movies on a train, right? Using the internet. I can stream videos live using the internet just about anywhere, anytime. Very convenient. No big deal. It's always on, right? These are things that no one thinks about anymore, right? It's always on. Like, how else would it be? Someone young might say, how else would it be? Of course it's always on. What do you do? You think it's going to be like a light switch you turn on and off? Well. If only it could be as convenient back in the day as turning a light switch on. But unfortunately, it was not even as convenient as flipping a light switch. So what was the internet for me as a child? Well, the internet, I think, initially was probably something I read about in one of my nerdy magazines, Popular Science, possibly. Maybe I heard something about it in school. I'm really thinking magazines. Some kind of magazine I was reading, because because without the internet, where else am I getting this kind of information? I would say magazines, possibly, because we're talking about cutting edge. You know, dating myself, but internet was something cutting edge. It was the future. let me, and you know, it's, I really, really got to give you the details because in order for people that were born in this age to really understand, I've got to really give you the details. So let me I can't just say cutting edge, right? We're talking about cutting edge to the point where the average person does not even know what it is. We're talking about it is something that is only in universities, and I believe, let's see, universities and who else? Who else? Universities and government. So that's where we're at, right? So I hear about it in some magazines, and I think my first time getting on the internet was with the purchase of my first computer. Now, if you look in the background of this live stream, there is, what am I doing right here? What's going on right here? What's this motion? I'm getting a little too comfortable on camera. That's what that is. But anyway, as you can see in the background, for you guys, it is over there. It is that way. That I can't even. I'm confused. It's this way. There you go. Over there. Over there on this side. Right there. You see this thing right here? That is my first computer. Or that was my first computer. That is the Tandy RLX 1000. It is an 286 computer. And that little hole you see in the front on the right hand side is the for the floppy drive. It was a 1.44 megabyte floppy. I remember, what was the big brand? Maxell. I won't say Maxwell. Was it Maxwell or Maxell? Whatever. And TDK. I think were two popular brands. So you had the 1.44, let me repeat myself, 1.44 megabyte floppy disks that would go in there. And that is how you stored your files. And everything was about, it was a disk-based time, because you would buy programs on floppy disks. You would store your files on floppy disks. Why don't you store them on your hard drive? Well, because your hard drive, wait for it, the hard drive on the Tandy RLX 1000 was a whopping 40 megabytes. Yes. 40, 80, I'm pretty sure 40. 40 megabytes. That's your entire hard drive. And I'm getting a little bit sidetracked, but so that's the computer. The computer came with something called if you are not very computer literate, you would call it a modem. A modem. That was stressed the E. Modem. I have a modem. I need a modem. Whenever someone says modem, you know, they're probably America Online customer. You've got mail. Anyway, so yeah, so it came with a modem, and that modem was how you were to connect to the internet. So let me break it down for you. Let me break it down for you. So we are talking about the early 90s, probably 1991, 92, 93, somewhere around there. So you had the popular speeds for the modem was 24, I think it was kilobytes per second was the data transfer rate. I believe it was 24K modems, and 56K if you really sprung for the really high performance modems. 56K I think it was called. Yeah, that's pretty slow. So I think I had 24K. What was it? Baud? This is so old now. I gotta look this up. 24. Let me see. Modem. I gotta look this up. Modem. 24K baud. I don't even know what I'm saying right now. This is the random stuff in my brain right now. I gotta look this up. I have to look this up. Let's see. So baud. What is baud? I don't even remember. Baud is like the data rate or something. Gotta love the human mind, like the brain storing. I got stuff in my brain I have to look up. I don't even know what it means. It's in my brain, but I don't know what it means because it's so old now. In telecommunications and electronics, baud is a common measure of the speed of communication over a data channel. Technically speaking, it is a unit for a symbol rate or modulation rate. I think I just got an email from one of my clients. Yep. They got overnight support. Okay. Okay, I'm gonna have to look at that in a second after the live stream. No big deal. I mean, it is after business hours, but I want to get the project moving as quickly as possible. So I definitely want to take advantage of the fact that these guys are available at night, so I can get some more progress going as opposed to losing the whole night and starting it again tomorrow. So I'm gonna respond to them a little bit. But anyway, so baud is basically like a data rate, so how quickly you can transfer information. Now let me get to the speed. So let's see, modem. Okay, 1224 bit per second. Wow. So I want to see. Oh, U.S. Robotics, 1994, 14,400 fax modem. Oh yeah, that's the next level. Fax modem. You got a fax in there too. It's a modem and a fax in one. That was like, whoa. You are really doing things, buddy. So let's see. 110 baud, 1958. Wow. 300 baud, 1962. 1200 baud. It doesn't say the year. Am I even pronouncing that properly? Baud? It's got to be baud. 2400, 1984. Wow. 4800 is, doesn't say the year. 1984, 9600 baud. 144K is 1991. Wow. 14. So I had a cheap modem. Was it 2400 baud? I remember that number. I later upgraded to like 9600, 14.4. I think even I had 19.2. Oh no, I had a 56K. That was in 1996. Wow, 56K modem. Okay, I'm not sure. I mean, the Tandy was about, probably had a 14.4. I don't know if it's 20. Whatever. That's the speed. And what does it mean? So 50. When you say 50, when you say 14.4, is that kilobits per second? It doesn't even matter. It doesn't even matter because I'm gonna qualify what you can do with that performance, and that'll tell you everything you need to know. So with that being said, so you have to have a modem, and the modem, I believe, connected to like a PCI slot. I think if you had a laptop, there was a PCMCIA, I think it was called PCMCIA cards. That was the thing. See, that's now we're talking some old technology. That is, laptops were small, so you didn't have these big PCI slots and stuff like that, and you're not putting these big cards in there. So they needed a way for you to do upgrades or to add accessories to your computer. Like, how do I add some kind of hardware to this computer that's not like a serial? Because we had serial ports. I don't think that, yeah, there's no, we don't use serial ports anymore. That's old school. You had a printer port. You had a printer port. Was it LPT? I can't remember. LPT1. I'm confusing myself. But there was a printer port. You had a serial port. You had a PS2 port. What else? What else was that? I can't remember. But anyway, if it's not connecting via a cable, right? Some of these would be like USB today, right? But if it's not connecting via cable, if it's something, and also if it's something, there's also the concept of external versus internal. I think that's what we're really getting at. You can add external devices and internal devices. So how do you add something that's internal? Because in theory, a modem, for example, you could add to a laptop. I'm pretty sure there's external modems back then. So it'd be like a serial modem, I believe. That would be most logical. So you have a modem or some kind of box, and then you can plug in a serial cable to the serial port on your computer, your desktop computer, your 8086 computer, and then use it that way. Or if you wanted to have an internal modem on a laptop, again, it's compact, so the idea of putting in there, not really a thing. So there was this interface called PCMCIA, which was basically these cards that you could put in the side of your computer. So imagine it's a card literally the size of like a credit card. Let's see, this is there's no credit card number here. So so just imagine something the size of this. It's probably, I would say, 10 times or more as thick as this card, but it was that size, and you could just slip it into the side of your laptop. So you'd have a modem in that format that you could just slide into this little door. You see the same way you guys slide in your memory cards today, like an SD card. You can just slip it in. Obviously, SD card is much smaller, but it's the same idea. Just imagine something a credit card size, but 10 times the thickness, that you would push into the side of this. There are two slots on the side, and then you would have this pressure, and then you could push it further and it would click, and now it's in. And it was like a little ejection button. So you get a modem in that format. And this is how this works. So you have this, let's say a desktop computer, you have this modem inside your computer. I believe it was a PCI slot it went into. And then part of it would be exposed in the back of the computer. So the way you install the card, you would see the little ports or whatever. And then there would be a phone jack. That's not the correct term, I'm sure, but maybe it is, I don't know. But it would be like a phone jack. So literally the same cable that you would use to plug in your phone, right? The same cable that you use to plug in your phone, you could plug that into the back of your computer and into your modem. Why would you do that? Some of you young viewers might be asking yourself. And those of you that just joined the live stream, go ahead and click on the like button. Definitely appreciate that. So why on earth would you be plugging in a phone cable to your modem? Remember, the point of the modem is to connect to the internet. So what's really going on? Why don't you connect your internet cable? Well, my friends, let me see if I can remember this correctly. This is old technology. I know the base concepts, but there's some details that I've forgotten or a little bit rusty because this is old, right? Maybe I was silly for doing that, but I didn't even do the research before this video. You are literally listening to me extracting probably 2-decade-old memories right now in real time. So bear with me. The reason why you connect the phone cable is because the way that you connected to the internet, if I remember correctly, was via the phone, obviously. I'm sure you figured that much out by now. And this is what happens. So think about a fax. It's a similar concept that the way, because faxes today, like a normal fax that uses your telephone line, pretty much that is in a way like, I would say, an alligator, and correct me if I'm wrong, but an alligator is to dinosaurs, right? An alligator is, if I'm not mistaken, there's some parts of that creature that is sort of reminiscent of dinosaurs a long time ago. So a modern day modem that connects to the phone system, it's very, very much, very closely related. I think there's not much has changed since then. I haven't used a modem, a fax in a long time, but I think it's really not much different from back in the day. So it's the same kind of thing. So basically the way you connect to the internet is your phone, your computer would actually call your internet service provider. So I think your internet service provider, your ISP, had an actual connection to the internet, right? And in order for you to access that connection, you would call your internet service provider and establish a connection to them. And by doing that, you now have access to their internet connection. I may be missing some details. But so the basic idea is your computer calls your internet service provider, right? And then there was this handshaking thing. I think you can still hear it today on a modern fax. You hear all this, like, this weird So it's like a handshaking process where your modem and I guess the modem at your ISP are sort of doing some kind of handshaking in terms of greeting, in terms of, hey, who are you? I'm such and such. I mean, not literally, right? But it's that kind of thing. You're establishing communication. I don't remember all the details of things that you would be checking, but you've got to be on the same page in terms of how you're communicating and that kind of thing. And then there's authentication as well, which I think comes next. Because I think the first thing is you do this, whatever that handshaking thing that happens, and then you establish. I think it's almost like you making a like imagine telnet to port and IP type of thing. So you have this connection established now, but now you want to go further and interact with some kind of application, right? So the first application you would interact with would be some kind of authentication application at the ISP. So it's like, who the hell are you? Right? So basically you get a username and prompt. Now, by the way, we are pre-GUI. We are talking about pre-GUI. So there's no interface. And I'm going into way too much detail. I'm really getting off topic because the whole thing is about why I'm so smart, again, being sarcastic. And I wanted to talk about like the magazines and stuff. And I was just giving you a little example of the kind of things I'm going to talk about in the series, and now it's becoming the whole video. I apologize. Bear with me. So anyway, I guess I don't need to go into details of how the connection worked, but basically you establish the connection and then you authenticate, and then from there you would be able to access certain, let's call them tools. One of them was like the web I don't want to call them browsers. It wasn't really a browser. Was it a web crawler? I don't remember what they were called back then, but they were web crawler. This is pre-web crawler. This is like Archie and I don't remember. But basically the key thing is that this was all text based. So you're talking about, it's like, imagine surfing the internet, well, was all done in a command prompt, right? All command prompt based. So when you're searching the internet, you're just seeing, just like, imagine you do Google searches today and you see the text, like that's everything. It's no more. Like now you see text and you click on a link and then you get the page with the videos and pictures and stuff. Back then you could select something. I think you have to use your arrow keys or something, and then you hit enter or something, and then you go to another page with more text. Anyway, so I think I've said enough. In a future video, I'll go into more details about some of the weird things that we had to deal with. I'll talk about, when we actually got to the point of video and pictures, what can you do with those kinds of speeds in terms of data transmission speeds? What was it like, trying to, again, when we started getting into graphical experience, so the World Wide Web, how long did it take to download a picture? How long did it take to download music? What kind of music did you see? And music used to be a thing, by the way. That was a huge thing. Web pages, you weren't happening if you didn't have music in the background on your web page. And a background image. But that's a whole nother story. So we're going to talk about that stuff. But so that's what the series is going to be about, talking about things like that, which I think are going to be very interesting for some of you younger viewers, and also some of the older ones as well, because it may be going down memory lane for you, right? So as for, again, my sarcastic video title, Why I'm So Smart and Why I Know Everything, let's talk about magazines. So as a child, I always had a thirst for knowledge, and I was always trying to learn something new. And I would always buy, or I don't know where I would get these magazines, because it's not like I had a job. I did have a job when I was young, newspaper route, for example, and some other jobs. But however I got these magazines, probably, my parents probably subscribed. I had a subscription, yeah. Oh, go parents, man. Go parents. It's such a great thing to have parents that are actually, try to inspire and motivate their kids and support them in terms of thirst for knowledge and things like that. I'm gonna take a moment to just be thankful for my parents' part in my success. Um, because who knows what my life would have been like if not for my parents who really pushed me to learn, and they saw, I had this interest in, like, I used to take apart my toys, which I'm coming full circle now because now with Arduino, wow, if you guys saw the live stream I did about Arduino, when I held that motor in my hand for the first time in probably 20 years plus, 25 years plus, right? It was such a nostalgic thing because that was me taking apart the lights, the motors, just trying to see how it works. And my parents saw that, and they try to sort of nurture that thirst for knowledge. And I think that's how they got me a subscription to Popular Science. And I used to read so many things. Crutchfield. I used to read a lot too. I think I was an automotive magazine or car stereo magazine or stereo magazine. I was very much an audiophile, so very much into car stereos and acoustics. I also got into I don't even know what the term is. Telecommunications. Maybe I guess it's telecommunications, but specifically radio, like VHF, UHF. I can't even think what that's even called, but I was very much into that as well. My parents actually even got me an old marine radio. Oh my goodness, I'm taking myself back. An old marine radio, an old VHF marine radio, and I used to play with that thing. And I think at one point I went to Radio Shack and I bought an antenna for it, but it's designed to operate in the water, so it didn't really work that well on land. But I would try to pick up anything and try to talk to people on it. But yeah, so they bought me these magazines and I would read them and learn about cutting edge, what's around the corner. And this is one of the reasons why I would say so. I won the science fair twice in a row as a kid in high school. And part of that was because of these things, because I was learning about next generation things. I mean, I knew about things that they weren't teaching you in high school and probably weren't really teaching you in most universities. I mean, obviously some engineering, specialty type situations, but in terms of, I'm more talking in terms of common knowledge. These are not like standard things that you would learn, because again, I was learning about the future, right? So I applied some of that knowledge into some science projects, and I also got to the point, I think through my participation in science projects. Where's my plaque? I got my plaque here somewhere that I won for the science fair. I won. What did I win? One of the years I won like a weight training set. Is that how I got my first bank account? No. I won. I don't remember. Oh, a Ben Ross watch. I got this Ben Ross watch, which I protected so well because it's such a nice watch that I never really got to wear it because eventually I lost it without ever getting to wear it. But anyway, so yeah. So, and I'll get into why I really got into computers and why I was studying it so much and why I learned so much. But it was through a lot of reading that I learned a lot. I got the attention of a local power plant. Was it an oil refinery or something like that? I think, yeah, oil refinery. One of the managers, I guess they probably had some kind of program where they were working with the schools or something, but they got wind of me and tried to get me a position to work at the plant. I'm like 15, 16 years old. I mean, wow, that would have been amazing. I mean, the money would have been nothing, but to a high school kid, it would have been a lot of money. I knew it would have been a lot. Their minimum salary would have been like a lot of money. I don't know what it would have been back then. But it would have been that would have been amazing. But I think I was too young. It was like a rule, some I don't know. I think maybe the special rules at a power plant or something like that. But yeah, I'll tell you one thing that I learned as a kid is that when you are really motivated and you're really really passionate about learning and um, things like that, adults. I don't know about today. I would hope so today, but definitely back in those days, um, they love that, man, and they love to try to help you out. Look at this kid who's trying to do something with his life and he's motivated. Let's help him out. Let's help her out, right? So I definitely had a lot of adults at various moments in my life as a child that reached out to me and tried to help me out, like this manager at the power plant. Um, I don't remember all of them. There were so many different opportunities that came up as a child because again, just adults being inspired and like motivated by my motivation, because a lot of kids just didn't care and they weren't motivated, didn't have any direction, and when adults see someone like me, they were just like, whoa, this kid is really going places. But I think to answer the question, and again, I was being sarcastic with that I know everything, that I'm smart. I mean, I'm not dumb. you know, it's as far as me being smart, I'm smart enough, but not smart enough that I don't have to work very hard to learn the things that I know. I mean, I work hard. The knowledge that is current, that is modern, that is applicable to my life today, came at a significant cost. I really, really had to buckle down and study and work hard and practice and what do you call it, index cards or whatever it is, different strategies, voice recordings I used a lot. And yeah, if I was such a genius, I probably wouldn't have to work as hard to learn things, but I do have to work hard. But I'm smart enough. But one of the reasons for the variety of knowledge is just my sponge-like nature, which a lot of that still exists, but not like when I was a kid. Um, I just always wanted to learn new things, and I always fed that desire with reading magazines and books and I had a lot of hobbies. That's another thing too. Why do you know about this? You know about that? Because I had the hobbies, right? I was into electronics. I took electronics in high school. Um, so that's where I learned about resistors and transistors and capacitors and soldering and using breadboards and all that kind of thing. AC versus DC current and parallel and series circuits. Photo what was it, photosensitive diodes and you name it. I learned a lot of that from high school, and also from being a child, taking apart my toys and trying to connect the motors to batteries. I mean, I was doing that from really young kids. So to someone older, you would think, oh, that's big deal. You connected a battery to a motor, but the basic concepts that you're learning there, that's a pretty significant learning event for a very very young child, right? To understand how electricity works and all that kind of stuff. But but yeah, so you have from that to my interest in telecommunications. I don't know if that's the correct terminology I keep using, but I was very much into like radio scanners, big into that. I still have my radio scanner. Wow. Oh man, I have. Oh, I gotta show you. I'll be right back. You guys gotta see this. I literally have it still. This is insane. Of course it's completely dead. Oh man, ran right into the microphone. Of course it's completely dead. We got a couple more people join the live stream. A couple more people just joined the live stream. Go ahead and click on the like button. I'd appreciate that. So this is the Pro 62. This is the Pro 62. um, radio scanner. People call it police scanner, which is definitely a misnomer. This picks up frequencies from, it was like 49 megahertz to like 850, 950 megahertz. I don't remember anymore. You can't even read the labels that I have on this thing. So this is my scanner from this scanner. Oh man, this scanner is, wow. Is this really? This has to be the original one. Pro 60. I gotta look this up now. Wow, this is. I'm gonna have so much fun with this. I hope you guys are gonna enjoy this series as much as I am already. I'm having a blast with this, going down memory lane. Let me see. Radio Shack Pro 62. I used to love Radio Shack. I'm telling you right now. Pro 62 scanner. So what year? What year? I think this is the original one, but I want to know what year. What year did they make this? So it's actually 30 megahertz to 960 megahertz. I was close. I was close. How was that for 20 plus year memory? So there's 30 megahertz to 54 megahertz, 118 to 174. See, let's see how much I can remember. Let's go down memory lane. All right, how much do I remember? What do these frequencies mean? All right, see, I'm gonna talk the talk. So let's see if I can talk. Well, let's see if I can talk the talk. Right. So, what are in these frequency ranges? And all I'm looking at is just the frequency ranges. So I got you guys. I could be reading it, but it doesn't. I'm looking at I can show you the page I'm looking at actually. 1 second, so we can keep this completely honest. So all I'm looking at is this article here. So all this shows you is the frequency ranges. So I want to see from memory how much I can remember. So, all right, so the first band, as you can see, is 30 to 54 megahertz. So in a 30 to 54 megahertz, you're going to have definitely phones. You have what do you have? You have wireless cordless phones, I guess they were called. Cordless phones, about 49 megahertz. 47 megahertz, possibly 47 megahertz, 49 megahertz, 50 megahertz. I want to say CB radio. I don't know if any TV would be that low. 50. I don't think so. I'm not sure CB radio, but definitely for a fact, I know 49 megahertz is cordless phones, or was. Cordless phones, back in the day, were unsecured. They were broadcast over unsecured wireless transmissions, or what do you want to call it. They were 49 megahertz and it was open. So all you needed was a receiver like this. This is a scanner, right? So it scans radio frequencies and converts them into a signal that the speaker, so you can hear what's being said, right? So if you had a radio scanner that was able to be tuned to the 49 whatever specific megahertz, 49.967 or whatever, right? Wow, I'm actually remembering. That's how much I used to play around with this stuff so much. I'm seeing the numbers in my brain still. 49.9.772. Wow. So yeah, you could hear people's conversations. Literally. Like it was open. So eventually they started changing. What was it? I think 900 megahertz. Did it jump to 900? I'm not sure, but I think the jump was to 900 megahertz, 930 or something like that, 920. Somewhere in that upper range was the more modern cordless phones, and that's where they incorporated some kind of security. I don't know what it is exactly, but if I'm not mistaken, Wait a minute, then there was cell phones too. Yes, no, cell phones were not that low. Cell phones were like 800. I think cell phones were 850 megahertz, somewhere in that range. So yeah. And then 118. Oh, yeah, air. I remember that. 118, 119, maybe 121 megahertz. I don't know about much higher than that, but definitely the teens, the 118, 119, that was air traffic control. Basically, that's frequencies that would be used by aircraft. So you could hear the towers and the planes coming in. And I used to love that, but that's another one of my hobbies. Why do I know these things? Because that's the short answer. Because I had way too many hobbies. I was very much into aviation, and as a result, that's one of the reasons why I got this. People say police scanner. It's a radio scanner. It scans radio frequencies. Police use radios, so they are one of the many types of transmissions you can pick up with this. Police by no way dominate the frequencies that you can pick up on this. It's a minor, just a fraction of what you can pick up. So one thing I definitely used to use these for a lot was to listen to aircraft. I loved it, hearing the aircraft taking off and landing. I'm really geeking out, but yeah. So 130, 140. You might find 144. It could be like fire. A fire department might be there somewhere. 170. You're getting into Marine 160, 160, 170. You're talking Marine transmissions, and then 380 to 512. 380 to 512. I remember picking up something in the 300 range. I think that's business VHF or whatever the hell it's called. I don't remember anymore. Business radio, I think, is in there somewhere. So that's like an office, that could be their office security. I believe it could even be like a McDonald's. McDonald's with their wireless headsets might be in there. And this is back in the day. 400, 440, definitely there was something in that. 440, I think, again, that's getting more business frequencies. 440. Oh, also TV. I think TV, there's some TV stations that broadcast somewhere in the 300 to 500 megahertz range. And you guys that are listening to this video, live or afterwards, correct me if I'm wrong and see how close I was to the actual truth, because it's been a while. It's been a long time. I would actually like to know how close I am to the truth of what these frequencies are. So 806 to 960 megahertz. So cordless phones, like I said, got into 900 range. I think cell phones back in the day, maybe lower 800s. I think this particular radio scanner excluded a lot of the cell phone ranges, so there might be some that are higher, like 970, 980 or something, or slightly lower. But that's it. That's what I remember. But anyway, so this is my Pro 62, which I wanted to find out how old this thing is. Look at all the features it's telling you about. 200 channels in one bank. Oh, ham radio. I forgot about ham radio. I don't remember what those frequencies were. I don't know if this can pick up ham. I think ham is lower. Ham is like super low frequency, because I remember ham, like their signals, and I studied about this stuff. Like there's a reason why ham radios can go so far, because of the type of signal. I guess based on the frequency, some of them are more directional and some of them are less directional. And there's also somehow there was a effect in the environment where I think you could somehow skip or something. Like there was a way where in certain conditions, you could get even a longer range with your ham radio or something. But there's something about low frequency, and it could be a sound. Remember, again, how do I know these things? Again, hobbies, right? We're talking about radio waves, but I don't know if audio waves is the term, but there's some parallels, because in my study of stereo systems and acoustics, I learned about the differences in the characteristics of low frequency versus high frequency sound. So, for example, with low frequency sounds, you have this a slower rate. You look at the waveform, a low frequency sound, you'd see like a sine wave, like that. I'm geeking out. I so wanted an oscilloscope. I was that nerdy kid who was what are we talking about? I don't know, 16 years old, and my dream was to have an oscilloscope. Oh my goodness. Well, anyway, if you look on a sound on a graph, you would see like a sine wave, and you would see this really, really smooth sort of wave for a low frequency sound, versus a high frequency sound. You would see much more aggressive waves, right? And one of the things you learn is the directional nature of sounds based on the frequency. So higher frequency sounds are more directional. So if I have a tweeter that's producing, high pitched sounds, and I aim the tweeter this way versus this way, there'll be a significant difference in how it sounds, right? If the tweeter is behind the couch, right, the couch is blocking the tweeter, it's going to be much more muted and much more dull, not going to be as clear, because high frequency sounds are very directional, right? But low frequency sounds are very I guess omnidirectional would be the correct term. So they tend to, like, you can't really tell where it's coming from in a way. Like low frequency sounds, they just tend to just sort of fill the room. So I think the similar principles apply to radio waves. So with higher frequency transmissions, I believe, are more directional and more susceptible to certain issues. I may be incorrect in some of that, but I believe lower frequency sounds, you can send them further. I could be wrong in that, but anyway, I'm pretty sure it doesn't tell you the year. I want to know what year was the Pro 62 made. Let me type in some years and see. 1992. Radio scanner guide. Let's see this. Oh, this is good. Oh, it was a Bearcats? I think that was a popular brand. I see BC. I think that's Bearcat. Yeah. I remember that. Bearcat scanners. Oh yeah. I think like Radio Shack, that was like, ooh, realistic. That's a Radio Shack scanner. Like Bearcat, I think was like that's the good stuff. So the Pro 62. Oh, there it is. 1994. Yes. This is the original scanner from when I was in high school. Wow. This scanner is so old. Wow, 94. 2004. 2014. How many years is that? That's a lot of years. Wow. Yeah, so this scanner is at least 2 decades old. I don't know. I think it still works. Whoa, look at that. Oh my goodness. It's so old. The plastic, look at that. I just opened the door. The plastic on the door container just literally just snapped out. Look at that. It literally just like an antique right now. It's just a battery. This is regular. It takes regular 6 AA batteries. I guess we didn't have lithium batteries, was not as popular back then. But this is pretty standard. So I could probably find another one of these. online somewhere, and then this will be one of my projects to actually fix this thing and get it working again. Maybe I'll do an Arduino radio scanner. Yeah, man. So I through having hobbies like this, I would read about them, study about them, and learn like all the stuff I learned about radio frequencies, how transmissions work, and all the I don't even know the words anymore. And then again, I was into car stereos. So I would learn about different frequencies of sound, different speakers, how speakers work, and by converting electricity into sound by the motion, right? You have the voltage, which triggers there's a coil. You see there again, all this random stuff in my brain. So you got a magnet and you have a coil. If you look at the back of a speaker, you'll see a huge magnet. Inside of the magnet, on the other side of the magnet is a coil, right? And then you would see like a little wire that goes from the coil to the cone. But whenever you introduce voltages, is that even a word? Can you say voltages? Voltage? I don't know. But when you introduce power to the speaker, I'm remembering a principle. This is actually good for me because with the Arduino stuff, I'll be doing electronics again. So it's good for me to sort of remember some of these things. So, let's see. So you can produce electricity by you have a coil and then you have a magnet. Oh, if I have a coil, like if this is a coil and I have a magnet and I move it around, I think that generates electricity, if I'm not mistaken. So there's an inverse relationship. By moving the magnet around a coil, you can produce electricity through the coil. But if you do the reverse, which is introduce a current into the coil, you could potentially make the magnet move. I may be missing up some details here, but I think that's kind of the principle. So introducing different voltages, which causes the motion with the speaker, which introduces the sound. So yeah, and then when I got into building car stereos, that's where I had to learn about the different components. You have the equalizer, you have the crossover, you have a high pass and low pass crossover, ground, the concept of ground, where the chassis of the car is the ground, even the car battery, how the car battery works. I mean, just so many things I had to learn to be able to build my own car stereo system, and that's really how I know a lot of the things that I know, just again from having so many hobbies. That what happened to my video? What happened to my? Oh, I guess it's just showing this thing here. So that's how I know what I know from having a lot of different hobbies, and from also having an attitude of not really having hobbies. And I gotta go to bed. Yeah, it is past my bedtime. I've been struggling with trying to get enough sleep, and now I'm here doing a live stream late in the night. So yeah, I'm gonna end this live stream pretty soon. But having a lot of hobbies and then not really having hobbies. What I mean by that, I'm kind of intense, and I always treat everything. I always treat everything like it's a big. I treat so-called hobbies like they're not hobbies. It's like I take anything that I'm doing, I take it very seriously. So So yeah, so I'm interested in car stereos. I want to master it. I want to learn every little detail about how it works, how they make speakers, how does the amplifier work. I'm reading these magazines talking about, the different speaker designs and, AC versus DC power and all this kind of stuff. And I do that with everything that I'm into. I'm into radio scanners, and I learn everything about that. I'm into aviation. I learned everything about that. I got into sound design. I learned everything about that. So that's how I end up being the man that I am today, with so much random stuff in my brain that people will be surprised, because I don't use a lot of these things anymore. I don't do these things anymore, so you wouldn't hear me talking about them. So if I all of a sudden start talking about sound frequencies or any of the things I talked about today, a lot of people who know me will be surprised, like, oh, what do you know about that? Actually, I've surprised some people. Like, for example, I could talk about aviation. I could talk about let's dive into aviation. Let's talk about the pitot tube. Anybody who knows about aviation knows what I'm talking about. The pitot tube, right? Let's talk about pitot. That's all I remember is pitot tube. You have your flaps, you have your ailerons, you have your rudder. Even the concept of landing, where it's a controlled crash, basically. So you come up on your approach, you reduce your speed to your landing speed, which is appropriate to the type of aircraft and your load. You have to consider the weight, also the wind speed, and these are all factors that have to be calculated or factored in. And then you get to your landing speed, and then initially, I think in your descent, how do you descend? You don't fly into the ground. That's crashing. You don't fly into the ground. What you would do is, it's not a controlled crash, more like a controlled stall. So what you would do is you're flying level flight. You come in for a landing. You start lowering your speed, and then you adjust your flaps, because what you're doing is you're changing your angle of attack, I think is the term, and it has to do with how the wind is hitting the wing. I mean, the way that the aircraft flies. Oh, let's get into what is it called? What are we getting into now? We're getting into I don't remember the term. Is it aerodynamics? I guess aerodynamics, right? The theory of flight. So you have pressure on both sides of the wing, right? You have the way the wing is shaped would be flat underneath and curved on top. Yep. So by doing so, I think you're creating an area of higher pressure below the wing, right? Because the wind is able to slip past the wing underneath because it's flat, but on top it's curved, so that breaks up the wind and I think creates almost like a vacuum effect. So that's how you have flight, right? Because of that effect. Something about the gradient between this wind that's going fast underneath and slower on top, I believe, and that's the lift. But when you are landing and you're changing your angle of attack, which I believe is the angle that the wind hits the wing, in order to maintain flight, you need to lower your flaps. Without that, you would not be able to have as high an angle of attack as you would with the flaps. So you put the flaps down and you start coming down. And so when a plane is coming down for landing, it's coming down like this, right? And then just before you actually make your landing, what they do is, I think it's called flare. You flare the aircraft. So what that means is you're actually going to pull up at the last second, increasing your angle of attack, and I think that slows your descent. Yeah, I think that's the idea. So you're coming down for a landing at a certain rate of descent, right? Certain rate in terms of how fast you're going down. And then to make a smooth landing, rather than keeping that consistent speed that you're going down, you're going to slow it at the last second. And the reason why you do that is because by making that aggressive move, by pitching the aircraft up like that, you're going to lose even more airspeed. And if you're in the air doing that, you're probably going to crash because you're going to start coming down really fast, right? Because there's going to be a point where you're bleeding speed and you're going to start. I think initially what's going to happen is the aircraft, when you pitch it up, is going to try to lift up, but it doesn't really have much power to lift up because you're going so slow. So all that's doing is really slowing your descent, right? So you're going down a certain speed and then you pitch up, so it slows it down slightly just before impact, so that at the time of impact, your descent is at such a slow rate that gives you a nice soft landing. Now obviously that's got to be timed just right, and that's why you have pilots that are better than others, where you've been in some aircraft that have had smooth landings versus hard landings. Well, that's why, because it's a little bit of a tricky thing to do. If you don't time it right, potentially you could end up maybe flaring it too late, so you don't slow the aircraft enough, so you hit the ground too hard. Or I don't know if this would normally happen in a professional pilot, but potentially you could flare it too early. Then what happens is you would slow down your descent, and then your airspeed drops to a point now where you're going to start descending again. But at this point, you can't flare anymore. You're already flared. So you don't have the method to cushion the landing. So now at this point, you're in a free fall. But this is happening just over the ground. It's not going to be too crazy, but that's just going to potentially make for a hard landing. But yeah, so and I was actually part of the Civil Air Patrol as well. But anyway, I'm rambling on and on at this point. This live stream went on much longer than I had hoped for. Hopefully, you guys enjoy this format and you enjoy these types of videos, because I enjoyed it, and I'm actually looking forward to doing more videos like this right here on the Fixed Protocol channel. So to everyone, I took all my Arduino time. I was going to play with the Arduino tonight, but obviously that's not going to happen because I decided to do this live stream. For what reason, I do not know. But I'm going to go and respond to this client so I can get things in motion before the morning and call it a night. So thank you for joining in. And if you enjoyed this, definitely click on the like button. And if you're new to the channel, definitely subscribe. Welcome aboard. And have a great night. Stay tuned for the next episode in the Techno Retro series. So learning about technology as seen through the eyes of an old guy. Bill Nye, the science guy. Okay. Anyway, on that note, thanks for watching, everyone. Bill Nye, the science guy.